class size homework involved practice problems calculating pH. First 1 through 5, you needed to use this equation. Now this is the equation for the self-ionization of water. Kw, the constant for water, is 1 times 10 to the negative 14 molarity squared. That is equal to your hydronium ion concentration in molarity times your hydroxide ion concentration in molarity. It's a very simple equation to work with. You have, in the problems, they give you one of these, and you solve for the other one. Problem number 1, it asks us for the concentration of the hydroxide ions. So if we take this equation, 1 times 10 to the negative 14 molarity squared is equal to hydronium times hydroxide, and I want to solve for hydroxide. I'm going to divide both sides by hydronium ion concentration. And so my working equation for that one is your hydroxide ion concentration is equal to 1 times 10 to the negative 14 molarity squared divided by your hydronium ion concentration. And in problem number 1, it was 3.98 times 10 to the negative 13 molarity. Molarities cancel out there, and your answer will be in molarity, and that makes sense because square brackets equals molarity. And in this one, you would have gotten 0.025. Now sometimes if your calculator's still in scientific notation, it would come out as 2.51 times 10 to the negative 2 molar. But that's the same number, so it's okay. Then you had one more decision to make. This was our hydronium ion concentration right here, and our hydroxide ion concentration was right here. We have to compare them to see which one is bigger. So as we look, this large negative exponent right here means this is a very, very tiny number. We've had to move it, we're going to have to move the decimal 13 places this way. So that means this number right here that only has one 0 after the decimal is going to be our much larger number. So we have more hydroxide, more base stuff. So this solution is basic or alkaline. Now, number 2 is worked very similarly. You're going to use the same equation, but I ended up with 1.0 times 10 to the negative 6 molar as my hydronium ion concentration. My hydronium ion concentration is going to be larger. This is a bigger number than this one. So we have more acid stuff, so it is acidic. Number 3, we're solving for our hydroxide ions, and you get 6.3 times 10 to the negative 9 molar. Again, it should be square brackets equals, then your units are molarity, capital M. This number is smaller than the hydronium ion concentration, so this one's bigger. We have more acid stuff, so that makes it acidic. Number 4, there was a little distractor here. You did not need to use that molarity at all. They gave you the hydroxide ion concentration, and that's all you need to work with this formula right here. So these are different because remember that ammonia is a weak base, so it doesn't ionize as much, so it doesn't produce as many hydroxide ions. Now, when we solve this one, we get 7.94 times 10 to the negative 12 molar. That number is much smaller than the hydroxide ion concentration. So we have more base stuff, so this is basic. Number 5, we're asked to find the hydroxide ion concentration. I got 1.7 times 10 to the negative 8 molar. These are regular numbers, so we follow regular sig fig rules by what's in the problem. This number is smaller than the hydronium ion concentration, but not by much. So we have more acid stuff, so this is slightly acidic. Now, numbers 6 through 10, you're working with pH. So we have Here are the formulas. All of these are given, so we can calculate our pH here. Now, this equation right here is actually given like this, but most of the time when you use it, you're going from POH to pH. So this is the way you use it most of the time, but pH plus POH always equals 14. It's related to this times 10 to the negative 14 right here. Okay, so with problem number 6, they give you the hydronium ion concentration, and in all of these they're asking for pH. Well, in problem number 1, you only have to use this top equation right here. pH equals negative log times the hydronium ion concentration. So for problem number 6, you take we want to find the pH. That equals the negative log of the hydronium ion concentration, and that is 6.2 times 10 to the negative 5 molar. You're going to type that into your calculator as 6.2 E, using our EE buttons, negative 5. And when you take the negative log of that, the pH comes out to, we know it's going to be close to 5, it's just going to be less, so it's 4, and then because this number has 2 sig figs, and we're calculating pH, then we're going to need to have 2 after the decimal, so 2, 1. This pH is less than 7, so it is acidic. If its pH is above 7, then it is basic. If it is equal to 7, then it is neutral. Now, number 7 works a little differently. Number 7 is going to be a two-step kind of problem. We're going to we cannot directly calculate the pH because in number 7 we are given the hydroxide ion concentration. So we're given the hydroxide ion concentration of 2.44 times 10 to the negative 4 molar. Because we have hydroxide, we cannot directly calculate the pH. What we can calculate is the POH. And then we know that pH and POH are related by the number 14, so it's 14 minus POH to give us our pH. So in the first part we're going to calculate our POH. Just do not mislabel it. This is not pH. Negative log of 2.44 times 10 to the negative 4. And we get a POH of, we know it's going to be close to 4, it's a little less, so it's 3, and then this number has 3 sig figs, so we need 3 after the decimal. 6, 3. Then we're going to use this formula right here to go from POH to pH. So pH equals 14 minus 3.613, and you end up with 10.387. The pH is greater than 7, so this is basic. The rest of the answers in number 8, you just have to take the negative log of this number because they gave you the hydronium ion concentration. And I ended up with 5.20. You needed 2 sig figs, so you need 2 after the decimal. And because this pH is less than 7, it is acidic. Number 9, you have to do the two-step method again. So we have the hydroxide, and you find your POH, and then you have to subtract your POH from 14. And I got 4.20, and it is acidic. Number 10, you had to do the two-step method again because they gave you the hydroxide ion concentration. So you take the negative log of this number, and then that's your POH, and then subtract it from 14. So I got a pH of 5.614. You needed 3 sig figs, and the sig figs are located after the decimal in both pH and POH. Because this number is less than 7, then the solution is acidic. There were 2 other equations that we worked with at the end of class yesterday. they involved, and they're really just the rearranged versions of these two equations. And they just kind of help you out. The first one is if I want to find my hydronium ion concentration and from pH, so I have 10 to the negative pH. Remember that this 10 is second log, and then that negative is important, so put negative and then enter in your pH. The reverse of the POH one is if you want the hydroxide ion concentration, it's 10, which is the negative log, or second log, negative POH. Now, you have to think about sig figs a little differently when you work with these formulas right here. If I have a pH equal to 3.14, well, in pH, where are the sig figs? After the decimal. So we have 2 sig figs. So when I use this formula right here to find the hydronium ion concentration, then I'm going to need 2 sig figs at the end. So I'm going to type this into my calculator. I have second log, negative 3.14, and I can put this in scientific notation. My calculator didn't automatically, but I ended up with 7.2, those are my 2 sig figs because this is a regular number, times 10 to the negative 4 molar. We can do this with the other formula as well. Usually it's used in conjunction with this formula again, knowing that pH and POH are related by the number 14. If I'm given the pH of 4.7 and they want to know the hydroxide ion concentration, and really whatever you're looking for, you need to find a formula that uses it. So I want to find hydroxide ion equals, well, that's this formula right here. Hydroxide ion equals 10 to the negative POH. Well, I don't have the POH. I have the pH. But I can easily calculate my POH. So 14 minus pH, just rearranging this formula right here. So 14 minus 4.7 gives me my POH. So I'll write this above. So POH is 14 minus my pH, which was 4.7, and that's going to be 9.3. So now I can use this formula, and what I would do is 10 to the negative 9.3. Now, the sig figs we can decide in just a second. So we're going to do second log negative 9.3. And now I can take my calculator back out of scientific notation. So I've got my hydroxide ion concentration as 5, because in pH, my sig figs are located after the decimal, and I only have 1. So that means I can only have, when I go to a regular number, and square brackets equals is a regular number, it's 5 times 10 to the negative 10. Again, square brackets equals molarity. Okay, I have a little activity for you guys to do. All the formulas that are given on this practice worksheet are given to you in the reference tables. So I want you to try and figure these out. Try and get the correct number of sig figs. But that is a process, and don't stress out if you don't get the sig figs just yet, but just give them a good shot.